for 3. Problem number 3 on 6.112 says f of x is equal to 0.4x, 0.4, I'm just going to write it as 0.4x minus 6. And the instruction says find the equation for the inverse, and then they want us to graph it. So what we'll probably do, we may do that on the, you're going to need graph paper for homework. So we'll talk about how to graph this. I guess I'll just try to do it by hand and draw a graph. It's kind of hard to do that on here because I used to have an app where I could pull up a piece of graph paper, not on this thing. So, all right. So if I want to find the inverse, the first thing I need to do is realize that f of x is the same thing as y, right? I could write my function this way. Now, what do I do if I want to find the inverse? What was step 1? Well, I need to do that, but first I got to switch the x and the y, right? That was one thing I have to do first. So I'm going to say x goes here, and then the y goes here. So that's this step right here. Switch the x's and the y's. Now I'm going to get the y by itself. You're right, that is part of it. Now solve for y. Get the y by itself. And I'm going to have to graph both of these functions in order to do part B. Okay, so if I solve for y, I'm going to circle it because that helps me know what to focus on, right? That's where I'm looking. I'm moving everything away from it. If I think PEMDAS backwards, I would say I'm supposed to add or subtract first, so let me add 6 to get it away from the y. That would cause that to add up to 0, and it would leave me with 4.4y is x plus 6. Here's my y. Well, how am I going to get rid of the 0.4? What will I do with it? Yeah, I'll divide everything by 0.4. I picked this one just because it looked particularly gross. 0.4 over 0.4 is 1y. Y is equal to 1 over 0.4. All right, so we used our calculators. We said 1 divided by 0.4. Someone did that, and it's 5 over 2x. And then what's 6 divided by 0.4? Let's make it a fraction, too. Somebody do that one for me on their calculator? Okay, thanks. Okay. So now, if I wanted to graph this, you see how it's easier if I turn it into a fraction to graph it? I'll graph this one in blue. We'll go back and graph the first one in red since I had it up above written in, or I'll graph it in black since I wrote it in black. So if I've got the y-intercept of 15 here, and this is going to be really hard to do, first of all, because it's got such a huge y-intercept, and I'm trying to graph on an itty-bitty thing. But if you remember, the slope is 5/2. I normally would start here and count up 5 over 2. What I can do, let me kind of put like 10 in here and 5 in here, and I'll try counting by 2s here. I don't know if this is going to work out for me. Oh, this is going to be a mess. This would be a mess unless you had a huge piece of graph paper, okay? But I would go down 5. I could go up 5 over 2, or I could go down 5. Remember, if we want to graph a positive 5/2, I can also think it as a negative divided by negative, and go down 5 to the left 2. So if I start here, it's down 5 to the left 2, down 5 to the left 2. It's going to look something like, oh, I missed it. If I undo it, it'll make the whole video glitch. So it's something like that. Let me graph the original one in red. This was 0.4x minus 6. Now if you think about 0.4, that's 4 over 10. That reduces to 2/5, right? So it would be, basically this equation would be the same equation as y equal 2/5 x minus 6. Okay, so it would have a y-intercept of negative 6. Let's say that's about right here. And it would be up 2 to the right 5. Maybe up 2 to the right 5. So it's going to end up being somewhere in here. Now that's a very rough graph, but hopefully you've got some good graph paper at home you could use to do these. Does this look like it's symmetric about the line y equal x roughly if I draw that line in? You could look on your calculator and it'd be a much better representation of it, but that's not too bad for just kind of eyeballing it. Doesn't it look like you could kind of fold those over on itself roughly, even though it's not perfect? That's how I know, that's one way I know they're inverses if they graph that way. And you know what, I know they're inverses because I use the correct method to find it. As long as I graph it correctly, and get a good picture of it, that's always helpful. But I did do the process to find the inverse, and I graph them, and I notice they're symmetric about the line y equal x. So that's kind of the point here. One question they asked me about these, are both of these functions? Do they pass the vertical line test? Is the blue one a function? It's a line. Yeah, all lines are functions unless they're vertical lines. Is the red one a function? Yeah, again, it's a line, and all lines are functions. So both of these are functions. So we found the inverse, and they're actually both functions. So sometimes that happens, and life is good. All right, so let's look at this one. This is a good reason. This equation right here is one of the reasons they put this inverses in this chapter. This is not going to be good. I can't really switch the x and the y and solve really easily. I guess I could, but we already know that if y equal 1.4x, do y'all remember that we can write it in its opposite or inverse form by changing it over? This is in, remember if I want to write this and label it, a lot of times I write it with the y over here. This is I C a B form. And if I want its inverse form, the inverse form is just log A, B equals C. So that would be, if I switch it over to its other form, that would actually be rewriting the inverse here. I could do the same process, but this is just an easier way to do it here, because these are kind of weird equations. The A here is 1.4, so it's log 1.4. The B is Y, and then the X is, the C is an X, right? So if I want to write this, I could change it over, but I still need to just do this. I still switch the x and the y at the end. So I'm still switching my x and the y, but instead of doing algebra to kind of undo it, I'm just rewriting in its other form. These two are inverses of each other. Here's the one written in the exponential form, and here's its inverse here. So what I did was, instead of just doing algebra to it, I just rewrote it using that I C of B and log ABC. Do you think it's going to be easy to generate a graph for log 1.4x? Calculator won't do it for you because it's not base 10 or base E, right? So what I'm going to do here is I'm going to graph this, and I'm not actually going to make the graph on the iPad just because it'd be a crummy graph, okay? But we'll talk about how we would get the table of values, and then you can translate it over into a better graph. What I would do is this. I would say, okay, let me make a table for this 1 to the 4th to 1.4 to the x power is y. And I could pick some values. I probably should pick like -2, -1, 0, 1, 2. What I'm going to do is go on my calculator and go to the y equal part, the function part, and put in 1.4 raised to the x power. And then I can go to second graph and get some values. And again, this is just probably the easiest thing to do is to graph it if you're doing it by hand. This is not going to be fun because for -2 it's 0.5102. For -1 it's 0.7143. For 0 it's 1. There's your nice value. My little lines are getting off here, my chart. For 1.4 to the first power would be 1.4. And then 1.4 to the second power is actually going to be, I'm just using my table, 1.96. So I could go graph that on my piece of paper. It would not be fun, right? Not look, you might want to make instead of counting by ones, you might want to count by something else. But in order to graph this one here, all I'd have to do is take those points and just switch them. And that's why this is in this section, is because they want you to know that that's what you can do. So it would be, if x is 0.5102, y is -2. If x is 0.7143, y is -1. If x is 1, y is 0. If x is 1.4, y is 1. If x is 1.96, y is 2. So you see how you would just flip those tables and then just graph by hand? That's what we would do there. I'm not going to do that just because it wouldn't look any good anyway on the iPad. Y'all remember, what's the first thing I should do here if I want to write this in a way that I can actually start doing something with it? Do I want to keep the f of x there? No, I wanted to make it y equal log 5 2x, okay? Now that's the original function. It's hard to graph that. That'd be kind of weird to graph. So what we're going to do is actually go find its inverse function, and that's what they wanted me to do anyway. and we'll graph the inverse function, or we'll come up with a table of values for it, and then we'll just flip the points to get the table of values we need to graph this one, and that's how we take care of it to keep it simple, okay? So this is, now again, if I'm going to write this and use I, C, a B, I'm going to have to make sure I put the log on this side. You know, I'm just going to flip the two sides of the equation so I can label it like I want to. This is log AB equals C, and to switch it to its inverse form, it would be I, C, a B. So my A would be 5, my C is Y, and my B would be 2X. So I rewrote it instead of doing algebra. What do I need to do now? I need to change the X and the Y. Remember how we still switch them out even if we've done this? This will be 5 to the X is equal to Y. That's how we find that inverse equation. So I switched the X and the Y after I rewrote it. So I'll put rewrote, switch X and Y, and then the last step is solve for Y, which that's not too hard to do. All I got to do is divide by 2. I would probably write this way, 1/2 times 5 to the X power. It's the same thing as 5 to the X power divided by 2, multiplying it by half. Let me turn this on. It's easier to make a table of values for this one than it is the other one. So that's what I'm going to do. I'm going to turn the iPad off while I do that just because this is just going to take, I'm just going to put it in the calculator and list the values. I'm running out of time on the video. Okay, so I've created that table there. I had to kind of, it was such a short little space, I had to kind of go to the side to finish my table out. Now if I want to go back and actually graph this log 5 2x, all I'm going to do is take that table I just generated and switch the points in it. So like when x was -2, y was 0.02, so I'll just switch it and put the 0.02 here and the -2 here. I had -1, 1, well I'll just switch it and get 1, -1. I had 0.5, so I just switch it and get 0.50. I had 1, 2.5, I just switch them. Y'all see all we're doing here is just flipping those points. Isn't that a handy thing to know, that you could do this rather than try to figure that out some other way? 12.5 and 2. So if I want to graph, the green function would actually be the inverse that I found, and the red function's the original function, but it was easier to actually go ahead and make a table of values to graph for the inverse function and flip it to actually graph our original function. That's why, again,